Hello, this is the investigation of differences presented with roll tapping and cut tapping of the aluminum alloys as a Penn State College of Engineering capstone project sponsored by Quaker Houghton. Quaker Houghton was founded in 1918 and is headquartered in Conshohocken, Pennsylvania, and currently has a presence in 25 countries as a global leader in industrial process fluids, serving a wide range of industries. Our problem statement for this project is to investigate the differences between roll, also known as form tapping, and cut tapping in aluminum alloy 356 T6 under varying conditions, materials, and metalworking fluids. Our primary project goal was to provide a qualitative comparison of cut tapping and form tapping by analyzing tool wear and thread quality. Cut tapping removes the material by cutting to create threads. This method requires less machining force to produce sharp threads, although they can be weaker and produce chips during the process. Form tapping molds the material around it into the threads. This method creates clean, strong threads due to material compression, although requires much more machining force and higher precision. Before starting the machining process, the selected tools need to know where to go on the block. We used a software called Mastercam to create a 2D model of our block as shown. This toolpath was our final design to utilize as much space as possible on the block to thoroughly test tool wear while abiding by the quarter-inch wall thickness minimum provided by Quaker Houghton. This is a simulation that can be used on Mastercam of our first toolpath design. Simulating the toolpath allowed us to visualize how the tools are going to function and react before uploading to the machine, which prevents crashes and damages. Once the toolpath simulation has been verified and approved by the team, it is exported as a G-code for the machine to read. Here's an example of what a G-code would look like. This is the machine located in the FAME lab that we have utilized throughout this entire semester with the help of the technicians. After the G-code has been uploaded to the machine, the 7 tools that were in total that were used were then installed and specific offsets were programmed based on the varying tool lengths. Once that's all been set, it's time to run the machine. Here's a short clip of the machine running during a cut tapping cycle. Here's how our first successful cut tap block looked. After machining, we took the used tap to this microscope and took up-close pictures to identify any built-up edge or chipping that could occur on the tool. Once completed with the blocks, we cut open the tapped holes to analyze the quality of the threads on the inside. As an up-close picture, on the left we have the form tap, which appears to be much cleaner on the inside in comparison to the holes that were cut tapped on the right. We identified failure of the taps when the threaded holes were no longer accurate enough to properly fit an M12 go-no-go tool. For the form tap on the left, it was after 176 holes and failed due to the form tap chipping, and on the right, the cut tap failed after 172 holes due to the tap dulling.